right, we looked at and said in the last video that we were going to decide why we wanted to factor quadratics, and we're going to talk about that in this fairly short lesson. We're going to look at a process that is called solving quadratics. And we solve a quadratic in one of numerous ways. There are lots of ways to do that, but the first one we're going to look at is to solve a quadratic by factoring it. And it's kind of an important process because it gives us a piece of information about the graph that we haven't had before. What happens is factors of a quadratic that are set to 0 give us the x-intercepts of the quadratic. And we've looked at lots of things on our graph before. We've looked at y-intercepts, we've looked at the vertex, we've looked at various individual points, but we've never looked at the x-intercepts. So if we solve our quadratic by factoring it or by any other method and set those factors equal to 0, we have the x-intercepts of the function. And so let's look at this one. X squared minus 5x plus 6 is equal to 0. You should be fairly comfortable at this point by saying, I need factors of 6 that add up to -5. And those numbers are -3 and -2. Well, if I take those and set them up as factors, x minus 3 times x minus 2, and this was an equation, so this is still equal to 0, I can use something called the zero product property. And the zero product property tells me that if I have two things that are multiplied together and they equal 0, then one of those things that I was multiplying has to equal 0. So let's set both of these factors equal to 0. X minus 3 is equal to 0. Add 3 to both sides. X is equal to 3. And x minus 2 is equal to 0. Add 2 to both sides, and x is equal to 2. Those are my two solutions to my quadratic. And if I sketch out a quick graph here and think about some of the things that I know about this graph, I know by looking at the value of c that this has a y-intercept at 6. So I have a point right here on my graph. I also know by looking at the value of a that this is a smiley face graph. It opens up. But I also now know that it has x-intercepts at x equals 2 and at x equals 3. So a quick graph of this allows me to say that this looks sort of like that. I have two x-intercepts, two places it crosses the x-axis. At x equals 2, the point 2, 0, and x equals 3, the point 3, 0. Look at another one very quickly and look at what the solution for the x-intercepts are on this particular quadratic. Let's start with x squared minus 7x is equal to -12. Wow, we set that up a little different from the way we set it up before. We need that quadratic to all be on one side. It's an equation, but we need it to be equal to 0. So we're going to say x squared minus 7x plus 12, I changed sides, so I changed signs, is equal to 0. Nothing left on the right-hand side of that equation. So if I want to solve this by factoring, I can simply look for factors of 12 that add up to -7. Those two factors are -3 and -4. This factors as x minus 3 times x minus 4, and that equals 0. Well, if I use the zero product property and set each of those factors equal to 0, I get x minus 3 is equal to 0, and x minus 4 is equal to 0. So if I solve both of these equations for x, add 3 to both sides, x is equal to 3, add 4 to both sides, x is equal to 4, I have the two x-intercepts of my function, 3, 0 and 4, 0. Just a note on terminology here. We have factors, which are generally binomials or monomials, terms in our function when it's factored. Those factors give us the x-intercepts, but we will also hear those x-intercepts called by some other terms. We will hear them called solutions. Sometimes we will call them roots of the function. Sometimes we will call them zeros of the function. And depending on exactly what we're doing with our problem will determine which term we use. But usually we'll say that x equals 3, x equals 4 are the solutions or roots or zeros of my function. If I write it as an ordered pair 3, 0, 4, 0, we will call it the x-intercept. And these x minus 3, x minus 4 are the factors of my quadratic. All right, so these give me the x-intercept of my function. Well, let's think about that for a minute. If I know that the factors give me the x-intercept of the function, can I use that backwards? Can I say that if I look at my quadratic on a graph, then I can get the x-intercepts of the function? And the answer to that is yes, absolutely I can. So let's look at 2x squared plus 7x equals 15. If I move that 15 back over, I get 2x squared plus 7x minus 15 is equal to 0. Now let's say I don't want to factor that. I want to solve it another way. Well, as long as I've got my calculator, I can graph this, find the x-intercepts, and that gives me the zeros of the function. So I press y equals, and in y1 I put in my quadratic, 2x squared plus 7x minus 15, and then I press graph. Now, if I'm using a standard viewing window here, the graph that I get is going to look like this. I'm going to have one side of my quadratic over here and the other side of my quadratic over here. And I'm not going to see this vertex. If you want to see the vertex, then you're going to have to change the window on your calculator. Let's say I don't care about the vertex. I just want to find my two x-intercepts. So I'm looking for this point right here, and I'm looking for this point right here. The calculator will find that for me. That process is similar to the process of finding a minimum or a maximum. I go to Second, Calc, and this time I choose the selection 0. And just like min and max, it asks me for a left bound and a right bound. It needs to know, do I want this x-intercept or do I want this x-intercept? So for the first one, I'm going to put a left bound over here and a right bound in here. It's got to be to the right of this point, but it can't be to the right of this one. We don't want two x-intercepts between our left and right bound. And then my guess can be somewhere in the middle. When I do that, the calculator will tell me x equals -5, y equals 0, which means I have an x-intercept at -5, 0, or if I've been asked for a solution, my solution is x equals -5. I then do the same thing with the other side of my quadratic. My left bound is in this section, my right bound in this section. Here's my guess. It will give me this point as x equals 1.5 and y is equal to 0. So my x-intercept is 1.50. If I wanted to change this to a factor, if I have x equals -5, my factor would be found by moving that -5 back to the other side, and my factor here would be x plus 5. And then I can do the same thing with the other one. If my x-intercept is 1.5, then I can say x equals 1.5. If I want the factor, I have to move that 1.5 back to the other side. And my factor is x minus 1.5. So I can work backwards from the graph and find the factors by just looking at the x-intercept.